For lesson 2, we only have one new formula on the sheet that we're going to be looking at today, and that's the formula for a pyramid. There's no picture because a pyramid is a general idea of a figure. So in the last lesson, we talked about a prism. In a prism, we have a shape on the bottom, the exact same shape on the top, and the figure stands straight up. In a pyramid, we have a shape on the bottom, and then instead of having a shape on the top, we just have a point. And that point should be exactly in the center of the figure. So the reason why there's no picture here is because that base could be any shape. So a lot of times we think about a pyramid, we think about the pyramids of Egypt. They had a square base, okay? They still exist. A square base, and then it comes straight up to a point that's exactly in the center of the figure. But the base could be anything, so we could have a base that's a triangle and it comes straight up to a point. Could be other shapes as well. These are just the two models that I have. Okay, so for the volume is 1/3 the area of the base times the height. This formula is very similar to that of a prism that we talked about in the last lesson. In the last lesson, the volume of a prism is the area of the base times the height. So the only difference here is this 1/3. What that means is, if I have a prism and a pyramid that have exactly the same base. Okay, so I have a square prism here, a square pyramid here, exactly the same size bases. Okay? What that means is I would have to fill this pyramid up 3 times to match what filling up just one of the prisms would do. Okay? When we cut it off to a point, instead of allowing it to stand straight up, we cut that volume down to just 1/3 of the prism's volume. Okay? And that's true no matter what shape that base is. So if the base was a triangle instead, as long as those bases are exactly the same size, filling up 3 pyramids is the same as filling up just one prism. So the pyramid has 1/3 the volume of the prism shape. Okay? The volume formula does need to be memorized for the test come Thursday. So for a prism, just area times height. For a pyramid, 1/3 of the area times the height. The lateral area formula does not need to be memorized, but it is 1/2 the perimeter of the base times the slant height. The slant height is the height that goes down one of the faces of the sides, not along where 2 faces meet. That's called a lateral edge, and that's something different. But right down the middle of one of the sides is our slant height. Okay? The actual height, when we talk about area of the base times the height, is like if I took a string and dropped it right from the point right down to the center of the bottom. That's the height. The perfectly standing up straight height is the height. The slant height is like sliding down the side of it.
Why is it times the slant height? Because couldn't you just use the regular height to...
What lateral area does is it adds up the areas of the sides, which are all going to end up being triangles. And so the area of a triangle is 1/2 base times height. So we end up with that 1/2 there because of that. The base is going to end up coming from the perimeter. And then the height is right down the middle of that triangle. So that's why we use that slant height. Good question. All right, so we're going to go ahead and go to our example problems. We're on the same notes page as we were for the last set of example problems. But we're just going to look at problems 6, 7, and 8 here because we didn't look at those yet in the previous part. Alright, so for number 6, find the base edge of a square pyramid. So we've got the base of this thing is a square. It's a pyramid, so it comes up to a point. Okay. You can draw them or not draw them, depending on whether you think that will be helpful. I'm a very visual person, so I like to see what I'm working with. We are given a height of 4. A height of 4 goes right through from the point directly down to the center of the bottom and hits at a right angle. And that height is 4. we are given a slant height of 5. The slant height goes down the middle of one of those triangle sides from the point. And that is 5. If we connect those two things, so they're both connected at the peak already, but if we connect them at the bottom,
Makes a triangle.
makes a triangle. And since this is a height, it's a perpendicular thing, so it makes an even more special triangle of a right triangle there. With a height of 4 and a slant height of 5. This is a pretty special right triangle, so maybe you already know the third side, and if not, we can just do Pythagorean theorem to find it. But what is that third side going to be? 3. Alright, this question asks us to find the base edge. The base edge is the length along the side of that square bottom. How does finding that 3 help us out on that?
Double it.
You can double it. So it goes from the exact center, and it's not, goes from the exact center out to the edge. So if we go out to the other edge then we can double that and get 6. Okay, so this question just asked us to find that base edge. So that base edge is 6, and we're done with the problem as what it asked for. I'm going to go ahead and take this problem further because your homework problems are often going to ask you to also find volume, lateral area, and total area. So we want to make sure we get practice on that. Volume, the formula is 1/3 the area of the base times the height. So 1/3 the area of the base. Well, if the base is a square with a side of 6, how do I find the area of that? 6 times 6, or 6 squared, times the height. And when we talk about the height, we're talking about that straight up and down height, and we're told that that was 4. So we can multiply that all together, and we get 48.
How the heck did you do that? That's the bottom.
How did I do that?
No, he did it.
Oh.
In his head.
His head.
It's crazy.
You just said find the base
36 divided by 3 is 12 times 4 is 48.
Didn't they just say to find the base edge though? Like,
They
is
did.
that what
I'm taking this problem further because your homework is going to ask you to do more than just that. So we want to practice like what your homework is going to ask
Are
you
we
to
ever
do.
going to use anything besides a square to do that?
Yes, you could use something besides a square base.
Like in this lesson?
Yes. Lateral area. The formula on the sheet is 1/2 the perimeter of the base times the slant height. I call the slant height S. The book calls the slant height L. I don't know, like L for like slant. I don't know, but I use the letter S. It doesn't really matter. That's what we want. And this one is not the height, but we want the slant height when we're working for lateral. 1/2. If our base is a square with a side of 6, then how would I find the perimeter?
6.
6 times 4. There's 4 sides of length 6. So counting around the edge, if I put a fence around the bottom of this thing, there are 4 sides of length 6 or 24. The slant height we were given was 5. So that is 60. Total area, we talked about in the last lesson, there are not formulas on the sheet for total area because total area is lateral plus bases as a general idea. When we were doing a prism, we had 2 bases because we had a top to it and a bottom to it. When we're doing a pyramid, we only have 1 base because the top is just a point and there's no area there. So we're going to take our lateral area of 60 and add to it the area of just the 1 base. And since that base is a square, its area will be 6 squared. squared. So 60 plus 36 is 96. Okay, so in the last lesson when we found our total area, we took the lateral and added to it the top and the bottom, so we had a times 2 there because the top and the bottom were the same. For a pyramid, it doesn't have a top, it just has a bottom, so we just need the area of that one base to add to it. Questions on that problem? We find the height of a square pyramid with a slant height of 5. Going down the middle of that side is 5. And a base edge of 8. And we are looking for the height, which drops right down in the center to hit at a right angle. So we can cut out that right triangle again. We do that, we know our slant height is 5. How does that 8 help us? Cut it in half makes a 4 at the bottom of that triangle because the 8 goes all the way across the side. Since that height hits right in the middle, it only goes halfway across the side. And then what would the third value be? 3. So then our height is 3. Once again, that's all the problem asked for, but I'm going to have us also do the volume, lateral, and total because your homework will, so we want to practice those. So volume is 1/3 area times height. So 1/3, since it's a square, its area is side squared. And the height we found was 3. I didn't get one.
The fourth beat.
The 5 is the slant height. We were given that. The bottom is 4 because that's half of the base edge that hits right in the middle. And then 3 for the height. So here we get 64 as our volume. Lateral is 1/2 the perimeter times the slant height. 1/2, since it's a square, its perimeter is 4 times the side. The slant height we were given was 5. You get 80 on that, I think. 16 times 5 is 80. I don't have a calculator in front of me.
Yeah, it'd be 80.
No, half in front of it.
Have been the half in front of it. So 16 times 5 is 80.
It'd be 80.
And then our total area is that lateral 80 plus the base, which is 8 squared. So 80 plus 64 is 144. Let's talk units. Your slant height, your base edge, and your height are all things that could be measured with a ruler. So that means they will all be a plane type of unit, a centimeters, inches, meters, whatever it is, but nothing extra on that unit because those could all be measured with a ruler. The volume is a cubic unit always, and area, both lateral or total, is a squared unit always. Okay, so the measurements within the figure itself that we can measure with a ruler are plane units, volume cubic, areas squared. Okay? Questions on that problem?
No, but this next one tells us.
The last one doesn't tell us it's a square, so the shape could be anything on the bottom. It tells us that the area of whatever it is 20, and the volume is 40. But it doesn't tell us what kind of shape it is. Since it talks to us about volume, that's where we're going to start the problem. Problem is with our volume formula. So volume is 1/3 area of base times height. If our volume is 40, we can plug that in for V. And our area is 20, so we can plug that in for A. And all we're left with here is H, which would be the height, and that's what we're asked to find, is the height of this pyramid. How do I get rid of that 1/3 on both sides?
Multiply by 3. 120.
So we're going to multiply by the reciprocal on both sides, and that will cancel it out. So that gives 120 is equal to 20 times H. And I get rid of that 20 by dividing both sides by it. I'm getting a height of 6. We could not, so in the last problems I had us do some extra stuff here. We can't on this problem because we don't know what shape the bottom is. And if we're going to go to find some lateral or total areas, we need to know the perimeter of that base, and we weren't told what the perimeter is, and since we don't know what shape it is, we can't find the perimeter of it. So this is really all we can do with this particular problem. We can't do anything extra on this one. Are there questions on that one? Alright, tonight your homework is the 12.2 part of the assignment. On number 2 and 3, it talks about finding the lateral edge, which is the length along where two of the triangles kind of meet each other at a corner. We can find it by using more Pythagorean theorems. In general, it gets pretty yucky, so we're just not going to deal with that. It's also not helpful to us in any of our formulas. We don't really need it. So we're not going to do anything that talks about lateral edge. So in those problems, do the rest of the problem. Just don't do that part of the problem. Number 9 is all about lateral edge, so we're just not going to do that one at all. Number 9, we're not going to do it all because that's all about lateral edge.